Right. Welcome, everyone. I just want to introduce you to let him introduce himself, David Birch with DPS. And thank you all for joining us today. And I'm going to turn it over to you, David.
Thanks. Hi, everybody. My name's Dave Birch. I'm the residential inspections manager here at Department of Permitting Services in Montgomery County. Some of you I recognized from being out in the field and other meetings, but as we go through today's presentation, I did want to point out that at the end, I've got the contact information. If anybody has any questions or follow-up that they want, please don't hesitate to reach out to me and we can get you the information.
Do you want to hold questions until the end, or if they have something in the chat or Q&A, you want me to let you know? Or
yeah, why don't we? Well, why don't we hold until the end?
Okay.
Basically, it's going to be broken out into additions, alterations, and then repairs and that type of thing. So, but I think we're going to cover pretty much all of it.
Sounds good.
Okay.
All right.
All right. Let me share a screen here.
Hi, Quasi. There you go. All right.
Now all I have to do is find my cursor again. There we go. There we go. Okay. Again, good afternoon, everybody. First, I'd like to start out by saying that this presentation was actually put together by the University of Illinois Center for Energy. Hold on one second. I'm sorry. The Smart Energy Design Assistance Center. They are a contracting agency within the University of Illinois that puts together slide presentations and educational webinars and seminars for municipalities across the United States, but mainly in Illinois. We found this presentation and kind of felt like, well, why reinvent the wheel? It's a pretty concise presentation, and they've given us permission to use it, permission to reproduce it. And if anybody wants the links back to their site, I can certainly provide that to them. They've got some nice webinars and whatnot there, informational. Now, I have made some modifications, very slight, but modifications to kind of explain some of the points to maybe some people that may or may not understand one concept in particular that becomes real important with the new compliance paths. Okay, so today we're going to basically talk about Chapter 5. And Chapter 5 of the International Energy Conservation Code deals with new and replacement materials, compliance for additions, alterations, repairs, and then in those cases of change of occupancies. We're going to go into each of these very briefly. We could spend way more than 45 minutes or to an hour on this. But if you have any questions, please don't hesitate. One of the things I want to talk about that some people seem to have a little bit of difficulty with the concept is weighted average U values. And we're familiar with R values. We see it on the insulation. We know that you can add R values. If you've got R10 in a wall and you put another R10 in there, well, now you have R20. What a lot of people aren't real conversant in is U values. And a U value is essentially the reciprocal of an R value. A little bit of math here. But you'll see U values on windows and doors, on metal frames, things that don't necessarily have an R value, but the U value is the inverse of the transfer of heat. And where this becomes important is an R value can be added and subtracted, but it can't be averaged. So if you have a wall that's 10 by 10 and it's R10 in there, and you put another R10 in there, that whole wall is R20. But then when you start looking at things like the framing factor, and now you're going to put a 2 foot by 2 foot window in there that's got a U value, you have to figure out a way to come up with the weighted average value of that assembly or that wall to resist the transfer of heat. And that's where U values come in. They can't be added or subtracted, but they can be averaged. And that's why we use them when we're trying to figure out the overall average R value of a wall. And I use the example of the 2 foot by 4 foot pull down ladder way that is in the attic. You can have I haven't done the calculation since we got to R49 and R60 in attics, but back when the code was R38, you can have an R38 perfectly installed throughout a 1,000 square foot attic. And if you don't insulate that 2 foot by 4 foot area, the overall weighted R value of that attic drops to about an R15 to an R20.
Oh,
All because of that 8 square feet of uninsulated space. So that's when you really get into the building science, the weighted average U value is how that's calculated. Okay. So when we get into compliance, in chapter 5, you've got 502, 503, 504, and 505, each of them pertaining to the additions, the alterations, repairs, and any change of occupancy. When we say change of occupancy, it's not in the strictest of terms that we see in some of our codes, but we'll get into that in more detail here in just a second. Okay, so our 501 is building maintenance. We know that buildings have to be maintained. They're required to be maintained in the level of the addition of which they were built. In other words, the performance can't be reduced. Of course, you can always increase it. Alterations versus repairs. So repair is for the maintenance of the building or damage. You've got a tree that falls into a house. We don't expect you to bring the whole house up to the new code. Sometimes permits are required on repairs, sometimes they're not. It depends on the level of damage or the level of maintenance that's going on. Tree in a house or a fire damage, that would definitely require a permit. And then in the process of obtaining that permit, that's when the old R values and stuff come in. Although I will tell you, here in Montgomery County, our philosophy is if you open up a wall, then the R value of that wall should be brought to the highest achievable level without going outside of fiberglass insulation. And what I mean by that is some of our walls literally have R10, but you open that wall up and that R10 comes out or is destroyed. 2x4 wall goes back up. We expect at least an R15 in that wall because that's the highest level of insulation that a 2x4 wall can obtain with fiberglass. Requirements for additions. An addition is an extension or an increase in conditioned space. or floor area, number of stories, or height of a building or structure. It's important that everybody understands that the new code would apply to the addition, but does not apply to the unaltered portion of the existing building or the building systems. And that's going to come into play quite a bit when we get into some of the mechanical stuff. So in the change of space conditioning, we're seeing this more and more with the accessory dwelling units being put into garages, into basements that may or may not have been conditioned before, or into detached garages. When you change the space conditioning, then the code applies. Exceptions for full compliance. So when we get into additions, because you're attaching to an older home, possibly, but because you're attaching to an existing home, I should say, they give an allowance of an additional 10% for the annual energy costs. So that interface between old and new sometimes isn't as tight as it should be, or may not be as insulated as well. And they allow that additional 10% of energy cost. Same thing if an addition is going into an existing building, as long as the UA value, that U value averaged, is less than the existing building was before the addition, then the addition is considered compliant. And where this comes in, and I've only seen this happen a few times, and this was a long time ago, back probably when the 2009 or 15 code. I remember a house that had glass all along one side. And they took all that glass out and they bumped an addition on and put far less glass in there. Well, by removing some of that glass, the weighted average U value of that structure went up because of the additional insulation in the non-glass area. When using R405, which is the total building performance method, if the addition plus existing building energy cost budget is less than the existing before the addition, then it's considered compliant. I don't think this group was going to run into this too often, because unless somebody has got the building performance software and a rater to figure out the level prior to the addition, this is really difficult to attain. So additions considered alone must meet the prescriptive methods, okay? The building envelope performance is not required for additions, because it wouldn't be fair to have you test the addition in the old house, because the old house is not going to pass. And it's very difficult to test just an addition and separate it from the house. So they've exempted that. Heating and cooling systems, the ducts, if they're extended from the existing system, they're exempt. Quite often we see this like in a kitchen bump out, or somebody's adding a breakfast room, and there's a trunk in the basement. There's already a duct right there at the window. Well, they're taking that wall down. They're just extending that duct 10 or 12 feet. That's where this would come in. If, however, you're putting an addition on that is going to require new systems, then the new system duct leakage must be tested. Sometimes we get additions that are far larger than the original house was. And they require additional, or I should say, additional systems, maybe in an attic or something like that. So those would have to be tested. And then in the service hot water systems, if you're putting in a new one, it would require the new system requirements or compliance. Building envelope, we kind of touched on this already. The new building assemblies that are part of the addition have to comply with one of these 4 sections, but additions are exempt from the leakage testing. There are some special applications. So R402.2.1 allows R38 instead of R49 and R49 instead of R60, depending on the climate zone, if 100% of the attic is uncompressed, fully insulated, and extended over the top plate. And we still go by that, depending on your compliance method. For fenestrations, area weighted U factor can be used. If greater than 50% glazed products, area weighted solar heat gain coefficient can be used. And if the addition is a sunroom or a heated garage that's thermally isolated from the house, in other words, that door has not been removed, then there are reduced insulation values that can be used for the compliance. And just a note, that reduced insulation does not apply to detached, heated, and cooled garages. If it has both heating and cooling, it does not apply. So how do we handle this? Well, we still, rather than do the blower door test, we're going to handle it by a visual inspection of the air sealing. You know, are the gaps around the windows foamed in? Are the cracks along the or between the double top plates caulked? Are the cracks between panel plates, are they caulked? That type of thing. Mainly sealing around windows and doors. HVAC systems, as you mentioned, if the ducts were extended, then they're exempt. If it's a new system, then they have to be tested. And one of the things that is a little different, well, it's a lot different, and I think it's kind of taken the industry by surprise, is under the excuse me, under the new code, all of the ducts must be tested. Excuse me, one sec. So whether it used to be that if the ductwork was all within the thermal envelope, it didn't have to be tested, but in this case, it does. They all get tested now.
David, who does that test? Is it something a mechanical contractor does?
Third-party raters are usually the ones doing it. We encourage that the mechanical contractors not test their own work.
Okay.
There's and it's really what we found is it's really tough for the mechanical contractor to maintain the credentials. If it's not your full-time job, it's tough to maintain those credentials because you have to have a quality assurance provider, and they come out and check your work periodically, and you have to have so many CEUs and that kind of thing, and the cost of that test just isn't enough to warrant putting somebody on staff just to do that.
Okay.
At least that's been my experience with it.
But that'll be a new cost for us in doing an addition where everything is within the thermal envelope. We should plan on having a third party test of the ductwork.
And I don't know what that cost is now. I know that it was reasonable. I know it was less than $200 when I was doing it. Haven't looked into it, so I can't really tell you.
Anyone else on the call now? All right, sorry to interrupt you. Let's keep
No
going.
problem. No problem. Service hot water systems, hot water, if you're using a circulator, then you have to have demand controls and you have to have insulation on that circulating water. Pipes insulated to R3. New lighting really isn't going to affect too much unless you're putting permanent exterior lighting in. And that's not too difficult either. It's a dimming, daylight responsive controls. And it's, I mean, anymore, it kind of comes with the lamp on exterior lighting quite often. The exception would be if the lighting is solar powered or controlled by motion sensors.
Can I interrupt real quick? Sorry. Can we go back to recirculating? Sorry, this is Doug with BOA. I thought demand recirculation was not required in 2021. That they'd reworded it so it says if demand recirculation is provided, it'll have blah 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 blah.
Right.
But it doesn't say that it's required for any recirculating system.
What I don't know is whether or not WSSC is still requiring. I was told that and I don't have it here in front of me, but I was told that WSSC was requiring it if the master bedroom was greater than a certain distance from the hot water source.
Perfect. I'll look that up. Thanks.
And I can get back to you on that too. I actually made a note of that earlier and I just didn't get it looked up. I apologize. Okay, so for alterations, an alteration is any construction, retrofit, or renovation to an existing structure other than a repair or addition. So in an alteration, only the manipulated parts of the building need to be brought into compliance with the code. So very much like the addition, you just can't make the building worse. Envelope alterations need to comply with all sections except for the air leakage test. Again, we're not going to require that an alteration pass a blower door test. Exceptions from compliance are storm windows installed over existing fenestrations, existing ceiling, wall, floor cavities exposed during constructions, provided these cavities are filled with insulation. Again, kind of like if you open up the floor and there's no insulation in it, we expect there to be insulation in it before you close it up. And then construction where the roof, wall, or floor cavity is not exposed, then there's no requirement to bring it up to compliance. Roof coverings, we don't require, I'm not a fan of this image over topping a roof like that, but we don't require attic insulation be brought up just by doing a roof cover. Roofs without cavity insulation and with sheathing or insulation exposed during alteration shall have the insulation added above or below the sheathing. Now, I'll add a little caveat to that. This isn't the case where it's a total roof ripoff. We're not expecting, and the code doesn't call it out, that if you've got, 2 sheets of plywood that need to be replaced due to roof rot, due to rot, we're not going to make you bring the attic insulation up to R60 or R49. For a roofing without cavity insulation that has sheathing or insulation exposed during re-roofing, the insulation will be added at or above the sheathing. You can see here that, what this guy's doing. we don't run into this very often. HVAC ducts newly installed as part of the alteration must comply as long as they're not just an extension. So mainly we're talking about something where you've, put in a new trunk, you've got a new, completely separate system being installed. And then again, we're back to the service hot water heater, and I'll get everybody an answer on that recirculation from WSSC. Alteration to lighting systems have to comply. Alterations that replace less than 10% of the luminaires in a space, provided the alterations do not increase the installed interior lighting power. Now, that's a whole lot of words that says if you're well, let me put it this way. If you're taking out 2 old incandescent light bulbs and you're putting in 4 LED cans, we don't see that as you increasing the interior lighting power. It takes a lot of 10-watt LEDs to come up to a 100-watt double bulb, old kit. I remember the ones we used to have in our kitchen, 200-watt bulbs in there. You can put a lot of cans in that place and still not be required. All right, let's talk a little bit about repairs. We don't really get into the repair too much unless it's like I mentioned, a car in a building or a house in a tree. I'm sorry, a tree in a house, fires, that type of thing. But repairs or reconstruction, renewal of any part of an existing building for the purpose of its maintenance or to correct damage, as I mentioned before. I think we pretty much covered that. I do want to talk about change of occupancy or use, though. So in the this seems to cause some confusion across the board. If I have a garage that's unconditioned space and I'm making it conditioned, that is a change of use. It's a change of, it may still be a garage, but you've changed it from a space of unconditioned space to a conditioned space. And by doing that, you've increased the energy consumption on the property. So that garage would need to come up to compliance. In the case of basements that may or may not be, perfectly conditioned, same kind of thing. We've seen some lately in the case of accessory dwelling units being installed, we've seen some very large sheds that are suddenly ADUs or accessory dwelling units. When that becomes the case, then those buildings have to come up to the energy code compliance. And I know that, we've gotten some pushback saying that, well, I'm not putting a heater in there. I'm not putting air conditioning in there. Well, yeah, it's still going to be conditioned space, though, whether they plug a space heater in or a window shaker air conditioner, it's still a conditioned space and it has to be brought up to code. Spaces that undergo a change in occupancy, excuse me, that increases the demand for fossil fuel or electricity have to be brought up to code. When using the simulated performance option in 405, if the total energy cost is 110%, in other words, an additional 10%, then it's considered compliant. Again, they don't expect it to be perfect. They don't expect all those connections to be airtight. So they do allow an extra 10%. So in a case like this, I mean, I'm pretty sure this was a car in a building. This would be a repair or an alteration.
Alteration.
No, actually, in this case, it could actually be considered a repair. It's damage to a building. They're not changing the structure. That's not to say that it won't need a permit, because the structure has obviously been damaged.
So
But
when do you need a permit for a repair? That screen that you had up a while ago had window glass is an exclusion to it. You don't want me to pull a permit to replace glass in a window, do you?
no. So we consider work that doesn't require a permit, and I don't have this in front of me, so I may miss it. It is on our website if you want specifics, but things like window replacement, same size, same location, window replacement does not require a permit. If you reduce the size of the window, that doesn't really need a permit either. If you increase the size, well, now we need to see what structural changes have been made. So that would require a permit. Roof recovering does not require a permit. Siding replacement does not require a permit. Let me think.
Well, looking at this picture, I see patching some brick. What is it about this that triggered that? There's structural elements here.
Structural element.
Yeah.
Yeah, as soon as you mess with the structure, it requires a permit.
So that would that be a good way to define when a repair permit is needed if there's any structural implication involved?
If there's any structural or electrical implication.
Mhm.
So quite often we'll see, you know, a small kitchen fire, for instance, and it may just have sooted up the kitchen real well, but the fireman got in there with the fire hoses and soaked down the walls, and all that wiring got wet. Well, now you need an electrical permit. You might not need a structural permit, you may not need a building permit if the fire didn't get into the structure itself. You're allowed to remove drywall. Remove and replace drywall, as long as you're not replacing any studs. If you're taking walls out, that requires a permit, because that's affecting the structure, even if it's non-structural. And we get some argument on that one. Well, it's not a structural wall. Well, no, but there's electric in it, and we need to make sure that the electric is properly terminated. And I mean, I've seen wires just yanked out of a wall and shoved back into the wall with wire caps on them, sometimes without wire caps. And so that at that point, it becomes an electrical issue. So here are my contact information. Bob Kelly is on here. He's the manager for the residential plan reviewers. Myself, and then Jeremy Shoop is my field supervisor. Do I have any questions?
I think we hit you with them as we went along.
Okay.
I actually have a quick one. I'm Rick Bird with Weedy Shower Systems. So I frequently get this question, at least lately, with regard to shower niche. So our products are a foam-based tile backer board, which have an R value of 4.3 for a 1-inch thickness. Our niches are 1/2 inch thick on the back and the sides, so I get the request or the inquiry as to whether they can put the niche on an exterior wall. Obviously, if that's done on a 2x4 wall, you're no longer able to maintain an R13 value in that wall, or R15. But is that acceptable in any way, I should say? Because obviously you're creating a spot where I suppose you could get a significant temperature difference between the exterior of that wall and the interior of the wall. Not in the shower itself, but between the back of the niche and the exterior wall. So there'd be potential, at least, for moisture there, at least as far as I know.
Right.
So basically, my question is, would that be acceptable or not? You'd still have to maintain proper insulation and then maybe build the wall out further into the interior in order to.
So how far does the niche, like in a 2x6 wall, how far does that niche project into the wall?
It's 3.5 inches deep. So in a traditional wall, 2x4 wall, it won't be touching the exterior wall, but it's pretty close. So 2x6 wall, obviously you have more depth, and you can put either insulation behind it or actually more of our board on the back of the niche to increase the R value. But my question is really more directed towards a 2x4 wall.
Yeah, and in a 2x4 wall, you say there's R3 on it?
It's 4.3 for 1 inch thickness, but the back of the niches are only a 1/2 inch thick.
Right.
So not very much R value there.
No, you're gonna have to, there's gonna need to be some way to,
Basically
in a 2x4 wall, that needs to get at least to, well, I mean, ideally, we'd like to see an R15, but, because I could see how that would cause, not only have a, cold spot with the niche, it would also cause moisture condensation issues with, if it's cooler outside and a hot,
Yeah. The
kind of
temperature difference.
yeah. Yeah, I would say that's gonna have to be built out. You're gonna need more, you're gonna have to get more insulation between that niche and the 2x4 sheathing on the outside.
Okay. That's what I figured. That's what I've been telling people, but I, just wanted to know for sure. I
Yeah.
usually direct them to check with their local code.
I mean, if you could get foam board back in there, even then though, if it's in a 2x4 wall, you don't have much room, you don't have any room.
I don't, there's really no extra room behind it. So the niche is, I believe it's 3.5 inches deep. Or maybe 3 3/4 total, including the 1/2 inch on the front that actually goes on the face of the stud. So you don't have more than probably 1/4 to 3/8 of an inch at the back between that and the exterior wall sheathing.
Yeah, even foaming behind it wouldn't do any good.
Yeah, no. Okay.
So isn't this the same as your example of the attic and the hole that the stairway creates in the entire assembly? Is this what the average U value would calculate? And
Absolutely.
that's the hole.
Yeah. Now, one thing that we don't want to confuse is, it's one thing for transference of heat. It's another thing for transference of moisture and condensation and those types of things. So, yeah, I think you could argue, and I could see that point where you could argue that, hey, I've got this, 1 foot by 1 foot niche, and yeah, that's going to be a cold spot, but overall, across this whole 2x6 wall, it has little or no effect. That's something that would have to be calculated, but my bigger concern would be the transference of moisture having that cold differential between the outside wall and that niche.
Especially because it's a shower.
Yeah.
Someone else asked a question about a recessed medicine cabinet, and
Yep.
it would really have the same implications.
Yeah.
I've
Yeah,
gotten used to telling people no on these, when we're designing the shower, just say it's not a good idea.
yeah, not in the exterior wall anyway, so,
Yeah.
but I think your point is well taken, that in the grand scheme of the assembly, it probably works out to something equivalent to having a window there, but with regard to the moisture aspect, then that's a completely different issue.
Yeah. I mean,
So-
I'm having an issue right now in my house, and I don't know why. I haven't delved into it yet. I'm like the cobbler who has bad shoes. But my microwave, I open the door and it feels like it might as well be outside. And the only thing I can figure out is when they put that microwave in, they didn't put any insulation behind it. But
or there's no damper there.
well, I looked for a damper, and frankly, I have not gotten up there because it's pretty high up on that side of the house. So I got to get a taller ladder to see if there's one out that I can't find yet.
Well, I mean, most microwaves, or a lot of them, will have a damper on the microwave itself, but that usually doesn't stop air, at least not very well.
Yeah.
So,
David, I have a quick question on the roof cover. In a case where you have an unfinished attic and you finish in the attic and doing a dormer. So I'm assuming when you do the dormer with a new roof, obviously you have to meet compliance for 2021. What happens to the existing roof cavity that is already insulated but is not compliant? Do you have to rip all the sheeting and bring it
No.
up to code?
No. So that's a good example for what I was talking about with under alterations, any part of the building that is not manipulated. In other words, you haven't touched it. It does not have to be brought up to the new code.
Considering the fact that it's not conditioned currently.
Right. And one of the things that we struggle with, and I know Mariella runs into this quite often, is, you've got, and we're starting to see it more and more now, but you've got, houses that had R30 in the attic and their roof line did not have raised heeled trusses. So now all of a sudden you want to put an addition on there on the end of the house, and you're trying to figure out, well, how do I match up the roof line with a raised heel truss?
That was going to be my next question.
That's where I thought you were going with the first question. So, I mean, we try to work with you as much as possible, but I'll tell you, it's tough, and it's all the only time I've, for a while there, we were allowing people to keep the roof line and then put as much insulation in the attic, do a U value for the attic so that we got the overall effective R value where it was supposed to be. Lately though, I've seen most people have just basically put it's almost like a false bump up. Like, okay, this part of the house is a little bit taller, but that's a good point of where the UA value comes in. If you can show in a UA value calculation of that roof that, hey, this is as good as or better than what was there, or this is as good as, because instead of putting So if let me put it this way, I'm kind of babbling here, sorry. If I do a calculation and I say, okay, I need to put R49 in this attic, but I can only get R30 out under the eaves and keep the roof line. Well, if I can put more insulation in the larger portion of the attic, say bump it up to an R55, or they blow it until they blow it. If you can show the U value is an effective overall weighted U value of what that roof would be at an R49, I don't think we have a problem with that.
That's good news then, because we don't want to end up designing wide overhangs or raised heel.
Yeah.
But that's a good
Yeah, I know that we did that. Well, before I was with the county, we did that in some projects that we were working on in Virginia. It worked out real well.
Thank you.
Just remember, no ugly additions.
There you go.
Are there any questions that we've missed in the chat? It looks like Mariella was answering a lot of them, so I think we're caught up, or is there something we're missing?
Wow, I must have had that portion shut off. I didn't even see the chat.
I think they've all been answered, unless not, someone can chime in. Anybody else? Let me peruse. I don't see any hands raised. Everybody's muted.
I do have one question about the insulation
Uh-huh.
above the ceilings. I know there's an exception that says if you can meet 100% coverage over the top plates, you can reduce down from, say, an R60 to an R49. But it also specifies that it has to be uncompressed. Is the uncompressed language apply to the R60 itself? So I'm just asking the question. So if I can get uncompressed over my plates, 100% coverage at R49, am I required to have uncompressed for the R60?
No.
So the R60 is assuming you are probably going to be compressing it in some areas. But
so I'm not sure if you're trying to put R49 over the top plate, why are you worried about R60 anywhere else?
well, I'm just kind of playing devil's advocate here because I feel like the language isn't clear. Like it specifies uncompressed in one area, but not the other area. So
because I think
guess
to do the R49, that would be a raised heel height. That would, depending on whether you're tying it to an existing or not, that would require probably like 15 inches of a cavity to be able to do that in the heel.
So in other words, so let me approach it this way.
okay.
So if I can put a raised heel truss in that will give me R60,
You
Well,
don't
let
need
me-
to do that.
right. Let me start out by saying this. Insulation should not be compressed. Okay, so that's rule number one. Insulation should not be compressed. So you can either put R60 throughout the attic, but not over the, and it may be less than that over the plate. Okay, over the top plate of the exterior walls. Or if you can get R49 out over the top plate of that wall, uncompressed, in other words, nobody shoved it under there, then the whole rest of the attic can be R49. Okay, and that came up with what we were talking about before, where the calculation was done of that 3.5 inch top plate, well, now 5.5 inch top plate, and the R value of that top plate and the heat transfer at that top plate. So they did the calculation and said, if we can get R49 over the top of that top plate all the way out to the eave so that the thermal envelope is continuous up from the wall and across the attic, then R49 across the attic is sufficient. If you can't do that, if you've got, let's say, your truss won't handle it and it tapers off right there at that top plate, then the rest of the attic must be R60. Okay, and again, it really comes down to that weighted U value average of the heat, and I didn't want to get into all the science of it, but that weighted U value average is used to determine the amount of BTUs that are transferred through the building material. You can actually, I haven't done it in a long time, so don't test me on it, but you can actually calculate the number of BTUs being lost through a wall based on the U weighted average taken in the 2x4s or 2x6s, 24 on center as opposed to 16 on center. A 2x4 has an R value of about an R4. Excuse me.
I think Jennifer is right in that it's poorly phrased. If they had simply said, give me R49, and then if you can't do that, here's the exception that takes you to the R60 and the compressing and all that.
I agree.
Yeah, it could have been said better.
So then, just to clarify, when it says 100% coverage, if I have an attic access, does that throw me out of the 100% coverage? If I have a chimney going through the middle of my attic area, does that take me out of the 100% coverage?
No.
No? Okay.
No. So if you have an attic access, like you're talking about coming down into the house,
Right.
yeah, those have to be insulated now.
But would it have to be up to the R49?
It's supposed to be.
Yes.
But what a lot of people do is they'll put a piece of bat insulation, and then they now have these radiant barriers that are pretty effective. They're not very effective as an air stoppage method, but they're pretty effective as a radiant heat barrier.
Okay, thank you.
You're welcome.
And check the chat.
If anybody has any questions for me, please just shoot me an email at any time. It doesn't have to be during these meetings. It can be, hey, this is what I'm looking at. Not sure how you guys are going to look at it. Let me know. I'll be more than happy to, let you know how I think we're going to see it. So.
I don't see anything else in the chat. Anyone else have any more questions? Right. We had a great turnout today. Thank you all so much for doing that. We will get the recording out. All of our recordings for these are on our YouTube channel. So you can always go there and find it. And then we will be back in for the next quarter. And anything else?
Thank you.
Bloom said thank you for the training.
Thank you very much.
Thank
Have
you.
a great one.
All right. You all have a good rest of your day.
Take care.
Thank you.
Thank
too.
you.
Thanks, everyone. Oh, let me. Recording.